Hi everyone, I am Dr.Peiris. Today I am going to show you the transformations of exponential functions. So in this video I am going to talk about only the vertical shift. So the topics that I am going to discuss are the vertical transformations of the exponential function, what is the general form, and then how to graph a positive vertical shift as well as how to graph a negative vertical shift. So the parent exponential function is given by this general form f of x equals b to the x, and in another video I explained and showed how to graph these parent exponential functions. So if you are not familiar with that, please watch the video about how to graph the parent exponential function, and then based on that you can continue with this video. So if we have an exponential function with the vertical transformation, we rewrite this parent function using this form. So this is the exponential function with the vertical transformation. The function is written as b raised to the x plus d. So this part is same as the parent function, and a constant d is added to the function. So this d is called the vertical shift, and if the d is greater than 0, the parent function shifts up by d units. If the d less than 0, if the d is a negative value, the parent function shifts down by d units. So since the function is going to shift up or down, which means the horizontal asymptote of the parent function also need to go up or down by the same amount of d units, which means the horizontal asymptote for a function with the vertical transformation would equal y equals to d. So the horizontal asymptote for a function with the vertical transformation is y equals d, which means what? It is going to affect to the range also, because the range basically starts from the horizontal asymptote, or it could end up at the horizontal asymptote depending on if the function is increasing or decreasing. So this is the range. Now let's see few examples. So the first I'm going to show you how to graph a positive vertical shift when the b is greater than 1. So these cases b greater than 1 and if the b is between 0 and 1, I have discussed in the other video where I explained the graphs of general exponential functions. So b greater than 1 means the parent function has a value of the b which is greater than 1. And if we look at this given function, f of x equals 3 to the x plus 2. This is plus 2, which is a positive vertical shift. So you see that this parent function is going to go up by 2 because of the plus 2. So this is a vertical shift plus 2. Now how do we graph this function with the vertical shift? So the easier way to do this type of questions is to first obtain the x and y coordinates for the parent function. So we first going to obtain the x and y for the parent function. So the parent function is 3 raised to the x. So let's first obtain the coordinates x comma y for the parent functions. So the parent function is y equals 3 to the x. Now these are the x values which I have chosen. So to make the math easier, we can easily choose these 3 x values. It is very easy to do the calculations if we choose -1, 0 and 1. So now we're going to substitute these values in the parent function and obtain the y coordinate. So 3 raised to the x. So the first x value is -1. So this is going to be 3 raised to the -1, which is 1/3. The second one, 3 raised to the x. Now the x is 0. 3 raised to 0 is 1. Third one, x equals 1. 3 raised to the 1, which is 3. Now we have the points for the parent function. Now what happened to the parent function? The y values need to be added to a plus 2. So which means we need to add 2 to y values, because the 3 to the x represent the y values and the plus 2 is added. So we basically going to add 2 to y values. So that is how we obtain the new y values. The x values does not change because nothing happened in the x direction. Only the y values go up by 2. So our x values remain same as -1, 0, 1. Now we need to add 2 to all of these y values. So the first one is 1/3 plus 2, so this is going to equal to 7/3 if we add the fraction 1/3 with 2, 7/3. And the next one we need to add, this is the second y value, we need to add 2. 1 plus 2 equals 3. And what is the second y value? 3. Then 3 plus 2 equals 5. So that is how we obtain the new y values. You basically keep adding 2 to all these y values. Now you have the points, so you can simply put the points and then graph it. First one, -1, 7/3. So we see that it is 2 plus something, so it is basically a point little bit above the 2. So it's the -1, and 7/3 is 2 and 1/3, so you can just put it like that. And the second one is 0,3. This is 0,3. The third one 1,5. 1,5. Now before we connect the dots, we have to make sure that we draw the horizontal asymptote first, otherwise we would draw it wrong. So where would be the horizontal asymptote? The horizontal asymptote is y equals the vertical shift. Vertical shift is 2 plus 2. So the horizontal asymptote is at y equals 2. So here is the vertical asymptote. The horizontal asymptote. It's the horizontal asymptote. So we draw the horizontal asymptote, which is at y equals 2. Now we have the dots, then we connect the points. So this is how this graph look like. So if we don't draw this horizontal asymptote, we might pass through that, so which make the graph wrong. So it is very important to draw the horizontal asymptote first all the time before you connect the dots. And now what would be the new range? So the range starts from 2 and then it goes to positive infinity. 2 to infinity. And the 2 is not included because the function is reaching to 2, but it will never be equal to 2. The range is 2, infinity. Now let's see the next one. So in this case, the b is in between 0 and 1. So the b is equal to half. So that's the difference. But this is still a positive vertical shift because we have +1. It's +1, but the b is a fraction. But we do the same steps. First we obtain x and y for the parent function. What's the parent function? This is the parent function, 1/2 to the x. So let's find x and y for the parent function. So again we choose the x values, -1, 0 and 1. 1/2, x is -1, so this becomes 2. Then 1/2 to the 0, which is 1. 1/2 to 1, which is half. And then our function is added a +1. So basically we need to add a +1 to these y values. The x values do not change. -1, 0, 1. Now we're going to add a +1 to these. 2 plus 1, this is 3. Then the next one is 1. 1 plus 1, 2. Next one is half. Half plus 1. So this is 1/2. So now we have all the points. And before we start, you can draw the horizontal asymptote. Horizontal asymptote is equal to the vertical shift. Y equals 1. We draw the horizontal asymptote, y equals 1, and the points -1, 3. The next point 0, 2. The next one 1, 1/2. Then we connect the dots. Make sure that we don't cross the horizontal asymptote. That's how we do the positive vertical shift. Very simple. And now what's the range for this problem? starting from 1 and it goes to infinity. 1 comma infinity. That's the range. Now let's see how to graph a negative vertical shift when the b greater than 1. This is the given function that we are going to graph. F of x equals 2 to the x minus 3. So we see now it's a minus 3. So this is basically a negative vertical shift. So first we are going to obtain the x and y coordinates for the parent function. The parent function is 2 to the x. So it's the same thing. We substitute these x values in here and then obtain the y values. The first one is 2 to the negative 1, which is half. Second one 2 to the 0, which is 1. Third one 2 to the 1, which is 2. Now we must subtract 3 from all of these y values. So the first one is half minus 3, it's minus 5 over 2. Second y value is 1 minus 3, negative 2. Third one is y equals 2 minus 3, negative 1. The x values remain same, negative 1, 0, 1. What's the horizontal asymptote? That's always equal to the value of the d. Now it's a minus 3. So the horizontal asymptote is y equals negative 3. We can draw the horizontal asymptote. Now mark the points. Negative 1, negative 5 over 2. Negative 1, negative 5 over 2. Negative 5 over 2 is negative 2 and half. In between negative 2 and negative 3. Next one is 0 comma negative 2. 0 comma negative 2. Then 1 comma negative 1. 1 comma negative 1. So this function goes like that. So in this case it crosses the x-axis. So this function going to have x-intercepts also. The function crosses the x-axis. Now what would be the range? So the range starts from negative 3 and then goes to positive infinity. Negative 3 to infinity. Now this is how do we graph a negative vertical shift when the b greater than 1. Let's see another example. So now we're going to discuss what happened to the function when the b is in between 0 and 1. So negative vertical shift of minus 2. The parent function is 1/3 x. So we obtain the values for the x and y. 1/3 x is negative 1, which is 3. 1/3 0 is 1. 1/3 to the 1 is 1/3. We need to subtract minus 2 from all the y values. So we subtract 2 from these. First one 3 minus 2 is 1. Second one is 1. 1 minus 2, negative 1. It's 1/3 minus 2 minus 5 over 3. And the x values is same, negative 1, 0, 1. Now where is the horizontal asymptote? It's at y equals negative 2. Y equals negative 2 is the horizontal asymptote. Let's mark the points. Negative 1 comma 1 and then 0 comma negative 1. 1 comma negative 5 over 3. So negative 5 over 3, which is in between negative 1 and negative 2. Somewhere here. The function is decreasing. What's the range? So we start from negative 2, it goes to infinity. So this is how we graph the vertical transformations. So I discussed all possible cases that we can have in a vertical shift. So that's all for today, everyone. Please watch my other videos also to learn more about exponential functions as well as other topics of the calculus class, pre-calculus class. And visit my website drpeirisclassroom.com. So that's all for today, everyone. I'll meet you again with another video.